Before we start graphing the polynomial or quadratic, we have to learn how to find the end behavior. We hear end behavior. What's that mean? It means the ending of the quadratic equations, how it's going to be, how behave. Going up, both sides, going down, both sides, one side going up, one side going down. So by just looking to the polynomial function, you're gonna learn how it look like the behavior or the end behavior of the function. It depends about check this is the general form of the polynomial function in general. And check here. We're gonna focus on the highest exponents, coefficient, and the degree. I have two cases. The coefficient with the highest exponents, if it's even and if it's odd. Odd number, I'm talking about the degree. If it's even, we have two cases. Depends about the coefficient. If the coefficient is greater than 0, that means positive. So the end behavior of the function from both sides going up. If it's negative, both sides going down. When we have odd degree and an is greater than 0, this side going up, this side going down. If an is negative, it's going to be the opposite. The left side going up, the right side going down. By just looking to the polynomial function or quadratic, you can check, okay, the end behavior is going to be this side going up or going down. It depends about what we have. Let's check this example. Here we have example 1. It says f of x equal x to the power 5 minus 5x cubed plus 4x. I'm going to look xn, the highest one. We have what? X to the power 5. What's the number here? 1. Which case is going to be? The odd or the even? Even. The odd. 5 is odd. So this number is odd number. Now I'm going to check the number here, which is the an. The an equal what? 1, which is greater than 0. So which case? An greater than 0. So the end behavior 100% is going to be like this. Now this side is going to be up, and this side is going to be down. I'm not going to care about how it looks like the function in the middle, because by doing the other steps, we're going to figure out how it's going to be the function between the end behavior. Okay. Our goal now is just to find the end behavior of the function. The same thing with number 2, but be careful. Number 2 is a little bit different. Question 2, we have what? Have g of x equal -2 parentheses x minus 5 and minus 5 and x plus 1. Now, I ask you find the end behavior. How does it look like the end behavior?
You gotta FOIL it. You gotta solve it first.
That's a good point, because we need this general form. I'm not gonna FOIL it. I've written in this form, okay? It's not the factored form. This is the general form, okay? Not the factored form. This one in the factored form. This one in the general form or the standard form. So if you look here, I'm not gonna factor it. You can do that, it's fine. But I'm gonna check. What's the exponents here? 1. That means here, the highest exponent is going to be x to the power 1. What about here?
Okay.
X to the power
3.
3, because the only thing I'm going to care is the highest exponent. Okay, now x times x cubed, x to the power 4. So x to the power 4. So when you FOIL it, the highest exponent is going to be 4. Now, -2 times 1, -2. -2 times 1, -2. So I'm sure 100% when I FOIL and multiply everything, the highest exponent is going to be -2 x to the power 4. But be careful, you have to multiply -2 times the number here, because sometimes there's a number and the number here. You got it? 100%, this one is going to be the highest exponent. That means n is even. So if n even, I'm going to look to the even side, and n equal -2, which is less than 0. So 100%, the end behavior from both sides is going to be those. Is that okay so far? How are we going to find the zeros for this polynomial function? Who's going to tell me? I'm going to help me with that. That means I need to find the solution. How am I going to find the solution? I need to find the x-intercept. It's the same thing. The solution, the x-intercept, the zeros. Now we have 3. When they ask you find the x-intercept, find the solution, find the zeros, it's the same thing. The x-intercept. How are we going to find the x-intercept? You're going to let y equal 0. So the same thing here. I'm going to say here is the 0 equal x cubed minus 5x squared minus 16x plus 80. Now what's the next step? Okay, this is the zeros. The next step, I need to solve it. How am I going to solve it? How am I going to solve this one?
Factor.
Have to factor it. How many terms? 1, 2, 3, 4. Remember, always when I'm start factoring the polynomial, I'm going to check if there's a greatest common factor. No, there's no common. There's 1 here, -5, 16, 80. There's a common here, but there's no greatest common with all terms. So now, how many terms do I have? I have 4. So if I have 4 terms, I'm going to factor by grouping. So we're going to group the first 2 terms and the last 2 terms. I'm going to check. Do I have common with the first 2 terms? Which is x squared. What's the left?
-5.
Minus 5. What's the common between the next 2 terms?
4.
Higher than 4. Yes, 16. So I'm going to put a plus or minus 16.
-6. No, wait. Plus.
Okay, now make a decision. Plus or minus?
Take out the minus, it'll be easier, I think.
Okay, so if you take the minus, okay. If you say I'm going to put the plus, okay? If you said I'm going to put the plus. So plus 16, right? But that's where you're going to get confused. You said I'm going to put the plus 16. That's 16. What's the left?
-x.
-x plus 5. Is that the same thing here? So what I have to do? I have to change this sign, change this one, change this one. So that's mean I'm going to take -16. So here's going to be what? +x minus. Now you can check that if you FOIL, I'll distribute -16, going to be -16x. Oh, baby. Now the same parentheses, be 0 equal x minus 5. What's that here?
-16.
16. Now, can I factor it more? I can't do anything with this one. What about this one? Is that minus between 2 squared? Or I can use difference between 2 squared. Because this one is 4 times 4, and this one is x times x. So again, I can open another 2 parentheses, 1x, 1x, plus or minus with 4 here. Okay. Now, how are we going to find the solution?
0.
Equal each parentheses to 0. That means 0 equal x minus 5. That means x is going to be equal 5. And 0 equals x minus 2. I have to put the parentheses. What do we call this method? Yes or no? X plus 2. That means x is going to be equal to -2. Remember the 0 factor property? When we equal 2 parentheses to 0, that's what we're using here.
Did you mean to put 4 up there?
Oh, it's 4. Why I put 2? Perfect. 4. So how many zeros do we have? How many solutions? 3. Is that the same the x-intercept? It's the same thing, x-intercept. So if I ask you find the x-intercept, maybe 5, 0, 4, 0, and -4, 0. It's the same thing. The zeros, the x-intercept, the solution, it's the same thing, okay? Now let's check here. So what I'm going to call these the result: zeros, or x-intercepts, or solutions. Okay. Now this form is the standard form. Okay. The standard form. Here's the standard form. The general form. What about this form? This form is the same thing here. But what we did to the side, we factored it, right? So this one is called factored form. So write it down, factored form. Each part here is called factor. Check here. This one, x minus 5, is going to be a factor, okay? This one is going to be a factor. This one is going to be. So you know what's the meaning of the factor? The factor came from the factored form. Each parentheses, before you solve it to get the zeros, is called factor. Now let's go to more advanced. Multiplicity, which is mean how many times is repeated this factor. How much the number here? So it's odd multiplicity by 1. How much the number here? Also 1. How much the number here? 1. So all these, it's odd multiplicity, or it's 1 multiplicity. If it's 2, it's going to be 2 multiplicity. If it's 3, it's going to be 3 multiplicity. Like this number is how many times it's repeated. You got it? For all these, only 1 time. We will see next example is going to be 2 times. So check this example. Now tell me, it's written in the standard form or the factored form? It's written in the factored form because you see it's already factored. Now, what do you think? How many zeros do we have? Or how many x-intercepts do we have? How many solutions do we have?
5, 6.
5.
6 now.
I ask you find the x-intercept. How many x-intercepts? You're gonna let y equals 0, right? So if I put 0 here, it's going to be 8x. X minus 1 squared and x plus 3. Now how are you gonna solve it? That means 0 equal 8x 0 equal x minus 1 square, and 0 equal x plus 3 cubed. Is that okay? How are we going to solve this one? Divide both sides by 8. That means the first 0 is x equal. It's the first 0. It's the first solution. It's the first x-intercept. It's the same thing. Now on this side, take the square root for both sides. We x minus 1 equals 0. That means x equal 1. Here, take the cube equal for both sides. 0 equals x plus 3. That means x equal 3. So how many zeros do we have? 3. Okay. Now, our goal is to do what on the last example. Now tell me, this one the first factor, this one the second one, and this one the third one. On this factor, how much the multiplicity? 1. So this one is 1 multiplicity. Okay. On the second factor, which is x minus 1 squared, how much multiplicity? 2 multiplicity. On the third one, which is x plus 3 cubed, how much the multiplicity? That means this one repeated 3 times. This one repeated 2 times. This one is only 1 time. Is that okay? That's the multiplicity. And we know how to subtract the factors. See, factor of the multiplicity. We already know. Now leave this one on the side. Now check for the first one. Which form is written here? Factored form. How many zeros do we have? We have 3 zeros. Let's check that. Tell me the first 0 here. X equal what?
0.
X equals 0. The second one,
X plus 1,
x equal 1, and here,
x minus 3.
negative 3. Again, what I told you is the same thing, the solutions, it's the same thing, the zeros, and what?
X-intercept.
The x-intercept. All these the same thing. The zeros, the solutions, the x-intercept. That's the important part when it's x-intercept on the graph. Because now I have a graph. Check these points. X equals 0. That means the graph intersect with the x coordinate at 0. Is that right? What else? You can check the graphs, you have it. And 1, and so that means when I need to graph the polynomial or quadratic, one of the steps I need to find the x-intercept. Is that okay? You will see. One of the steps is to find the x-intercept, exactly what we did here. X-intercept, y-intercept. We don't care about the y. But the important, how much the multiplicity on the first 0, or the first factor is 1? Keep in your mind. When it's odd multiplicity, 1, 3, 5, 7, 9, odd multiplicity, the graph is going to cross at x equals 0. You got it? X equal 1. Is that odd multiplicity?
Yes.
So check. At 0 is a cross. At 1 is cross. The graph cross at the point x equal 1. 3. How much the multiplicity? Odd? 1. It's odd multiplicity. That means at negative 3, the graph cross. Is that okay? So write it down. When it's odd multiplicity, the graph is going to cross. The cross at the point when it's odd multiplicity. Is that okay? So write down here, cross. At these 3 points, it's going to cross. We will see on the next one how it looks like. Cross, that means at this point, one of these points, the graph It's going to cross. Go into another direction. Is that okay? Let's go to the next one. How many factors do we have? 3 factors. How many zeros? 3. The first 0, x equal.
0.
The second one, x equal. The third one, x equal. -3. Now let's see here. On the x equal 1 is odd multiplicity, right? On x equal 1 is even. X equal 3, -3, odd. That's important on the graph. Let's see. Where is x equal -3? This one. If it's odd, that means it's going to cross the point, right? So check here. The graph came from here and across at x equal -3. That's okay, that's fine. Let's see when it's even. Where is the point? 1. Here. What happened to the graph?
Stop.
Don't stop. It's touch the point and going up. It's not going to cross. So it's touch the point. You see the graph? This is the point -1. The graph come to this point, touch it, and go up again. It's not going to cross. So that's the difference. When it's even, it's gonna touch the graph. Let's do a simple graph here. So let's say this is x equal 1, right? Let's say from the bottom, the graph go to this point, touch it, and go back. So just touch the point and go back. So this one is going to be, because it's even multiplicity. I'm not going to care it's from down, from up. It's just the graph, touch it and go up again. Now let's see when x equals 0. It's x equals 0, right? It's odd. You see the graph? It's across the 0 because it's odd multiplicity. Is that fine? Can we do the same thing with the last graph? The first 0, x equal, and x equal, and x equal -3. This one is odd. This one is odd, and this one is x equal -3. Check what happened to the graph. The graph touch the point and go up again. Is that okay? At x equals 0, it's odd. What happened to the graph? The graph is across the 0 to the other side. Because it's odd multiplicity. What about x equal 1? It's odd, so the graph is gonna cross 1 again. Now let's check the end behavior because we have 3 graphs. How much the highest exponents here? First of all, x times x times x. So it's x cubed. 1 times 1, 1 times 1, so still 1. That means an is 1. Odd. How does it look like the end behavior? Right down here. X cubed. This is the an, which is 1. So an equal 1, which is greater than 0. So the right side going up and the left side going down. You see? We found the end behavior from here because it's help when you graph it. Now let's check here. How much the exponents here? 1. 1 x times x squared times x the 4. So here is going to be x to the power 4. Now I need to check 1 times 1, 1 times 1, also 1. That means an equal 1, which is greater than 0. The exponent is even, so both sides going where? Going up. Is that okay? Can we do the same thing here? It's the same thing exactly like this example. So both sides going up. This is the first step when we graph the polynomial, finding the end behavior. Next step, we're going to find what? The x-intercept. So, step 1, find the end behavior. Step 2, Find the x-intercept. Step 3, find the y-intercept. Because we need point. We need point to graph it. So the first step, find the end behavior. Second step, find the x-intercept. Third step, find the y-intercept. So now we have 3 steps. Is that okay?
What was the third step again?
The y-intercept. Yes. Example 5.
Identify the zeros of the function and whether there is a cross point or each
At each zero.
At each 0. So first of all, where is the zeros? We already did that on the previous examples. So the first 0 is 3x squared equals 0. Solve this one. X equal what? 0. Because you're going to divide it by 3 and take the square root then both sides. Do you want me to do these steps?
No, it's okay.
Fine. So x equals 0. This is the first one. Now the second one is x equals -4. The third one is x equals 7. Then they ask you, first of all, for the first 0, it is odd or even?
Even.
It's even, it's x squared. So it's even. So the first one is even. The second one, odd. The third one, odd. Now, how much the multiplicity here?
2.
Oh, they ask you, well, it's 2. How much the multiplicity here? 1. How much the multiplicity here? They ask you, it's a touch or cross. Here is touch or cross. Touch. Here. Here. That's it. That's what they're asking you. With degree 4, how many turn points? You have, let's do an example. Let's do an example here. If you have f of x equal 5x to the power 4 plus 6x cubed plus 3x plus 2. Okay? If I ask you how many the degree has, how many turning points? You're going to take the degree, which is n minus 1. So it's going to be n equal what? 4 minus 1, which is equal to 3. So the polynomial has 3 turning points. That's it.
We take the highest.
The highest, because it's the degree. The degree of the polynomial is the highest exponent. Okay? What about the leading coefficient? How much the leading coefficient? 5. The leading coefficient is the number with the highest exponent. It's leading for the function. Okay? This one is give you the turning points. It's positive or negative, right? With the exponent. Is that okay? If the highest exponent here is 14, how many turning points? 13. It will be 13 turning points. Is that okay? Okay. That's what they ask for an example. 6. Number 6. What they asking you?
Maximum number of turning points.
What's the maximum number of turning points? Look to the graph. They give you graph.
3.
No. 3 is the highest. 3 is the highest degree. How many turning points? Look to the graph. How many turn points? The graph came from here. 1 turn, 2 turn, right? How are we gonna find that? Because we need to graph this one. So I say, okay, how much the degree here? N minus 1. So the degree here is a 3. Minus 1 is going to be 2. That's mean 2 turning on the graph. Is that okay? So now, to graph the polynomial function, step 1, we're gonna factor the polynomial or the quadratic equations. Step 2, we're gonna find the end behavior. Step 3, find the x-intercept. Step 4, find the y-intercept and then extrapolate. Okay? Now let's start. Do we need to factor this? Already in the factored form, so we don't have to factor. So I'm gonna go to the next step. So you don't have to do step 1. Go to step 2. Find what?
The end behavior.
End behavior. Now let's see. How much n here? This is the highest exponent. Be careful. Because it's you have how x squared times x cubed. X cubed times x to the power 4. So write down, that's what you're gonna do when you have factored form. Okay? Do not go to the highest exponent, it's going to be wrong. Because this is the factored form. This is not the standard form. Okay? Now it's x to the power 4. Now let's check. You have number here? It's 1. 1 times 1 times 1 times 1. So still 1 here. Now an equal 1, which is greater than 0. Yes or no? This one is even. How does look like the end behavior? Both sides going where? Both sides going. That's it. This is step 2. Is that okay?
Pretty much we're gonna have to memorize that, right?
Like if you memorize it, it's good thing. I'm not gonna force you to memorize it because you can use your notes. But be honest, I'm trying to memorize it. So always, if you memorize it, you're gonna figure out without keep looking for your notes. Is that okay? Now, next step, we have to find what? X-intercept. X-intercept. How are we gonna find the x-intercept? Let y equal 0. Where is y? That means 0 equal x minus 1 squared, x plus 3, and is that okay? How are we gonna solve it? 0 equal x minus 1 squared. Take the square root for both sides. So x minus 1 equals 0. So how much is the value of x? 1. As a point, x-intercept is going to be 1 and 0. Because this point, we're going to graph it. Is that okay? Now I'm going to ask you, on this point, is the graph close or touch? Go back to the factor. Go back to the factor. It's square. So it's touch the graph. You got the idea why we need to learn touch or cross? Now let's go to the second one. Solve this one. 0 equal x plus 3. So x is going to be equal -3. As a point, -3 and 0. Now let's go back. At this point, it touch or cross? Cross. Last point. 0 equal x minus 4. So x is going to be equal 4, which is mean 4 and 0. At this point is going to be cross. So I already have 3 points. I know which one you can write down. Touch, cross, cross, so you can know. Okay. Next step to find what? Y-intercept. Step 4, right? Y-intercept. You're gonna let x equal. Go back here. You're gonna put 0 here, 0 here, and 0 here. Y is going to be equal 0 minus 1 squared, 0 plus 3, and 0 minus 4. Do like this way. -1 squared, 1. 0 plus 3, 3. 0 minus 4. So it's going to be what? Negative 12, right? That means as a point is negative 0 and negative 12. Just a point. We need points so we can get the graph. Okay. So now how many points I have here? 3. How many points I have here? 1. That means the total is 4 points. I'm going to use these 4 points. And next step, it says extra points. If I need extra points, I'm going to pick any points on between these so I can graph it. Is that okay? If you need. So I'm going to put step 5 here if we need extra points. Five, 10. 5, 10.
When we find the y, do we check if it touches or crosses or?
No, the y, don't worry about it. The y, it just cross and that's it. It's never going to be touch the y and goes to the other side. No, the problem with the x. That's a good question. Yes. It's y-intercept. That's it. It's a cross.
Crossing.
Yes. But with the x-intercept, when it touch, it is still x-intercept. It's not gonna cross. Now let's check. Put all these points.
That has a by 10.
But the main thing, you get the idea how to graph it. The extra points only if needed. Before I used to be check. I didn't follow the. I'm telling you, I'm being honest. I'm not following touch or cross. So I just follow my imagination. So I'm gonna say at this point the graph is going. It's gonna be here or here. It doesn't make sense. If this one is touch, it doesn't make sense. It's going to be goes down to this one. It has extra point. The graph is going, but until where? Because some graphs until this side, going here and go back again. Some graphs going really down. You see it with this one. So I used to be like doing the same mistakes, like just follow my imagination how to graph it. But you get the idea. How many steps? 5. And behavior, x-intercept, y-intercept.
Factor first.
First of all, factored form. Always you need to write down in this form. It's gonna make everything easier for you. I'm telling you. When you find the x-intercept, you don't have to factor it. Already factored form, you're just gonna equal each one to the 0. Okay? It's easy to find the x-intercept. We will see, I think, next example, right? Last example. This is a theorem. Just a graph. Now let's check before we go to this example. Said how much the highest exponent? 4. How many turning points? 3. Let's check here. So here's 1, 2. How many turn the graph did? This is the first turning point. This is the second one because it goes down. And then the third one because it's going to go up. So that's why when they ask you the turning points, that means how many points the graph turn in it, which is how many 3. We will do the same steps on the next one. Step 1. It's already in the factored form, right? Step 2, you need to find the end behavior. X, how much the exponents here? X to the power 1 times x squared is what? X cubed. Now let's check. 1 times 1, 1. And there is negative 1. Negative 1. See what I'm doing? Is that okay? So an equal negative 1, which is less than 0. And the exponent is odd. So the end behavior is what? The left side is going up or down? The left side, the left side.
Going up.
On the right side, don't. We're done from the system. Next step. X-intercept. How are you going to find X-intercept? Put 0. So I'm going to put what I'm doing. Put y equals 0 here. Means 0 is going to be equal negative x plus 1 x minus 3 squared. Why you say the 3? How many x-intercept do we have? 2, because don't worry about negative sign here. It's not negative x. Okay? You get the idea? It's not negative x to consider it as a 0.
A negative 1.
Negative 1 equals 0. Did you put negative 1 equals 0?
X equals 1.
No, that's going to be wrong. Be careful. Okay? So don't worry about the sign here. Even if it's negative 3, it's not negative 3x like what we have in the previous example.
It's only if it has X.
If it has x, yes. We have 2 zeros. That's mean I'm going to say 0 equal x plus 1. So x is going to be equal negative 1. The first x-intercept negative 1 and 0. From here, so x is going to be equal 3. That's mean 3 and 0. Now I'm going to ask you, at this point, the graph cross or touch? Cross. At this point, cross or touch? Touch. Depends about. Okay. Step 4 to find what? Y-intercept. We're gonna let x equal 0. That means y is going to be equal. Put 0 here. So it's going to be negative. Be careful. 0 plus 1. 0 minus 3 squared. Y is going to be equal. Negative. Here is 1, and here is negative 3 squared. So the y equal negative 3 squared, 9. Times 1, 9. Times negative 1. That means the point is 0 and negative 9. Is that okay? Piece of cake. Let's do a simple graph here. Now let's graph. I didn't go to step 5 because I said if I need to do step 5. X-intercept -1 and 0. So here's the first x-intercept. And the next intercept is a 3, 1, 2, 3. Y-intercept is 0, -9. Is that okay? Now I said the end behavior from this side going where? Up. So from this side, the graph is gonna go up. From this side, the graph is gonna go where? Down. That's it. I don't care about what's gonna go. Up, down. Now let's check here. Tell me, at this point, the graph cross or touch? It's a cross, so it's gonna cross here, goes where? To the y-intercept. Then goes back where? At this point, the graph cross or touch? Touch. You can tell the graph is gonna go touch this point and go down. Is that okay? Piece of cake? So you can write down this straight line. If your scale is going to be, the graph is better.